As she said, hello everyone. I have 23 minutes to do 109 slides, so we will get started. The reason I wrote this talk is because the write-ahead log in Postgres is a fundamental part of the system. It does so many things. What I'd like to do in the next 23 minutes is outline what that write-ahead log does. You've probably heard of the write-ahead log. The gentleman before me was talking about crash recovery. That's one of the things it does. But it does many other things, and I'd like to explain. So first I'd like to talk about what is in the write-ahead log. Then I'd like to talk about the next four things that Postgres does with the write-ahead log. The write-ahead log is basically a change log for the database. That means that it records every change that happens in a central location. And it's used for crash recovery, point-in-time recovery, binary replication, and logical replication. It was introduced in 2001 in Postgres 7.1. Point-in-time recovery was added in 2005. Streaming physical replication in 2010. Replication slots in 2014. And finally, logical replication in 2017. I believe there's a logical replication talk this afternoon. Somebody's actually talking about logical replication, and maybe right now, actually. This is a diagram that I think explains how the write-ahead log works. The write-ahead log is the part here on the right. And basically, any time a session makes a change to the database, it records something in the write-ahead log. And as part of crash recovery, that write-ahead log is flushed to the kernel cache and then to durable storage so that it can then be used for crash recovery as well as many other things. Okay? Let's take a look at what is in the write-ahead log. You might have seen these files, but you may never understood what was inside. So we're going to install an extension called WAL-Inspect. WAL-Inspect allows us to look inside the write-ahead log. And I'm going to create a function which allows me to simplify the write-ahead log, and I'm going to write a couple more functions. So it turns out that for an empty database, these are the types of records that appear in the write-ahead log. Okay? I'll talk about that in detail in a minute. We'll also use this function, and we're going to just walk through the different things that happen. One of the write-ahead log things is related to indexing, the B-tree index methods, and it creates these types of records in the write-ahead log. There is a database type of record in the write-ahead log. There is a heap where the heap files are stored in, data is stored in heap files. You can see an insert record here, an update record, and a delete record, all part of the write-ahead log. There are also things like multiple row inserts and things related to vacuum. There's checkpoint records, and the gentleman before me talked about checkpoint records. Those appear in the write-ahead log. There are update records that appear in the write-ahead log related to the relation map. There are records related to standbys, records related to creating storage files. Commit records, every time you issue a commit, that generates a record in the write-ahead log. So for example, if I do a create table here in red, here in blue, you can see it generates these records. This create table generated a B-tree insert record, a couple heap records, some storage records, and finally the commit record at the end. If I do an insert, that generates insert records and an index record and a commit. Update, similar, generates update records and a commit. Delete generates delete record and a commit. So you can kind of see, as I said before, the write-ahead log contains changes, and these are sort of statistics of those changes. Okay, if I drop a table, that generates similar records in the right-hand log. Okay, insert, so forth. This is some of the detail. If you look at the record, the right-hand log record, you can actually see how long it is, the LSN, and a description of that record. There's a commit record, and it tells me the time the commit happened inside of the right-hand log. Here is an example of a more detailed record. This 0002 is literally the insert that I did. When I did an insert back here, I inserted a value of 2. And that is the 0002 that you see down there at the bottom. That's literally the insert value that I created. Okay. If I enable logical replication, it does some more things, full page images. The gentleman before me talked about that. Okay. And again, this is one of the major things that the right-hand log does. And the reason it was originally created was for crash recovery. Okay? So the way crash recovery works is that effectively when Postgres crashes, you're left with the data files that are in an inconsistent state. Okay? The gentleman before me talked about how crashes recover the right-hand log. It's good that they put him before me so we can explain some of the details. So this is what it normally looks like when you crash, your database crashes or your operating system crashes. You can see the heap files are not consistent. But we do have, remember, records in the right-hand log. And what do those records contain? They contain changes. They contain the changes necessary to fix this problem. So we basically start out Postgres and we read the changes from the right-hand log. We pull them into the right-hand log buffers. We go into recovery, and we actually start cleaning up the inconsistencies in the storage. And you're going to notice as I go forward, the inconsistencies get dimmer, and then they finally disappear. Okay? So that's what crash recovery is. It's reading the right-hand log, writing down to here to fix the inconsistencies until the inconsistencies are done. Once the inconsistencies are done, we can then start up a normal Postgres and go back to normal operation. So if Postgres is ever, if your operating system has ever crashed and you start up Postgres and it took a little longer to get started, what it's doing is going through that crash recovery. Okay? Here's an example. What I did was, here's a right-hand log record right here. Okay, I know it's a big long number, but that's the way it looks. Okay? So what I did was I inserted a string, Postgres is awesome. Alright? And I went to look at the right-hand log and I said, is this string in the right-hand log? And yes, it is. Okay? And then I waited until a checkpoint finished. And a checkpoint is an operation that causes all the dirty shared buffers to be forced down to disk. And once I wait for the checkpoint to happen, I can then do a search, and it will then show me not only the data in the right-hand log, it will also show me that the data is now in the data files. Okay? Because normally, you make a change to the database, it gets written to the right-hand log right away, there's a delay before it actually gets written to the data files. Okay? This is the way the checkpoint works. It basically identifies all of the dirty shared buffers, and it writes those down to storage until all of those are fixed, and then we can then recycle these right-hand log records, and our checkpoint is finished. So that's the way a checkpoint works. Okay? If I crash, simulate crashing the database here, I say long live relational systems. I insert that into Postgres. And you can see that it's in the right-hand log, but it's not yet in the data files. Okay? Because when I did the search, it looked in the whole data directory, it only found the right-hand log, didn't find it in the data files. Okay, just one place. Remember I said it gets rid of the write head log first, and then I crash Postgres. Okay? And then I start it up again. Okay? And you can see I haven't started yet, it's still only in the write ahead log. That's the only place it is. But then when I start Postgres, I go through these red records here. And you will see this in the server logs when you start up after a crash. It will basically replay the write ahead log. Remember I told you about the arrow that goes up and brings it down? That's exactly what's happening here. Then it says checkpoint complete. And now when I look for long-lived relational systems, it's in the write ahead log, but most importantly, it's in the data files. So I have not lost the commit because it went in the write ahead log in crash recovery. Because I hadn't run a checkpoint yet, automatically restored that row that had not made it to the data files yet. And now, if I do a select, I have both my records, Postgres is awesome, and long-lived relational systems. Okay, the second thing that the write ahead log does is continuous archiving or point-in-time recovery. In this scenario, not only is the write ahead log written to the file system, but it also gets stored in another location. We call that the write ahead log archive. Okay? The write ahead log archive can be very big. It may be days or weeks of write ahead log records in that write ahead log archive. Okay? So to use point-in-time recovery, you basically take a backup of the file system, the heap and index files, and use something like PG-based backup to create a backup of the data files and indexes. But you also have the write ahead log that goes with that. Why is that write ahead log important? Well, it's important because we're backing up a file system that's being changed. Right? We're doing this PG-based backup while Postgres is running. We didn't shut it down. So therefore, when we do a copy of this is going to be dirty. This is going to be all corrupt here. But we know that's not a problem. Why is that not a problem? Because what did we learn during crash recovery? That the write ahead log that was active at the time the backup was taken is able to make this consistent and working, right? We saw that. So we're now doing the same thing, except we're doing it with a write ahead log archive. It could be very long, and we're taking a copy. We didn't do a copy during crash recovery, but now we're taking a copy. And of course that copy can be corrupt, but we have the write ahead log that goes with it. Okay? So how do we do a restore? We take this corrupt backup, we put it right here. We take the write ahead log that was active during that, we put it here, and we start running. So what we have are corrupt heap and index files. We have this write ahead log here, okay? So what happens is that this has been copied here. We start reading here, we get here, it gets fader, and then it gets fixed. And then, because we're doing point-in-time recovery, we're going to now use this. And as I said before, we may have days or weeks or months worth of data here. So now we're going to feed this into the write ahead log, and it's going to do the same thing. It used this to fix this problem, right? Now we're going to take this and we're going to start going forward by day, by hour, by day, by week, and we're going to continue playing the write ahead log files to advance that heap and index files forward in time. That's what point-in-time recovery does. Okay? And then we get to this point where we've recovered as far as we can, and now we can start a normal operation, right? Because we've used this to fix this, which we restored here, and then we use the continuous archiving to replay and move our time forward. Okay. Let's take a look at this. we're going to turn archive mode on. We're going to create an archive command. We're going to restart the server, okay? Then we're going to look at the archive directory. This archive directory is this directory right here, okay? We're going to look for that directory. And right now, there's nothing in it. So we're going to issue a command, switch right ahead log. All of a sudden, now we have one file over here now, okay? One file, because I forced the switch. If I take a look, I do a directory list, you can see right here. There it is. That's the file. It's in the archive directory. Okay? Now, we're going to test it. We're going to we're going to insert a pre-wall switch message. You're going to see, as soon as I issue the wall switch, that appears in the archive directory. All right? Now I'm going to have a pre-backup message. Again, that normally just appears in the archive directory. It also appears in the data files. Okay? Then I'm going to have a post-backup message. I'm going to switch again. That's going to appear in the archive directory. Okay? So now we're going to do a point-in-time recovery. We're going to remove the data directory. We're going to copy our base backup. We're going to basically restore from the archive directory. We're going to start ourselves up. And there it goes. It's taken the 3 rows that were not in the base backup. They weren't in the backup I took in the file system. The only place they were in the archive directory. One was done before I did the right-ahead log switch. One was done before the backup of the file system. And one was done after the backup of the file system. And they're all there. Okay. Archiving is still on, and again, you can set that up. One unusual thing is that because I've done a recovery, I get what's called a new timeline. If you've ever heard timeline before. Every time you do a new recovery, you get a new timeline. Okay. All right. We're going to talk about physical replication. I have about 5 minutes left. In physical replication, what we're going to do the same thing as recovery. We're going to take our heap and index files. We're going to use base backup. We're going to make a copy, just like before, right? We have our corrupt index heap files, and we have our right-ahead log. But instead of recovering it, what we're going to do is we're going to put that base backup somewhere else, a different machine maybe. Okay? So here's my corrupt heap and index files. Here's my right-ahead log data, and here's my archive. Remember this from before. So what I'm going to do is I'm going to start up a new server. This is my new physical replica. And I'm going to use the corrupt heap and index files, and I'm going to use the right-ahead log, and I'm going to use the WAL archive, and I'm going to start fixing the corruption that happened because the base backup took a backup of a live file system. It's going to dimmer, it's going to get fixed. Now, I'm going to pull from the archive directory, and I'm going to move forward, okay? And then I eventually get to a point where I can effectively, from the worker, send a network. Every time somebody commits a message, it gets sent over the network to this replica. This replica replays the right-ahead log, and it also changes the shared buffers to match. So we now have an active system. There are no changes. Notice over here, these are doing writes to the database. There's no writes, we're just reading, because it's a replica, right? All the changes to this replica are coming in either through the WAL archive or more typically over network connection from the primary. Okay. How do we set this up? We set up a network connection right here. Now we can effectively insert one row, and now we see one row in the replica. I can do an update. I see the update on the replica. If I drop the table on the primary, the replica, it generates an error because the table's gone. Okay. This is you can actually set up a hierarchy of replicas here, which is kind of nice. replication, basically this is a little different. In this case, to set up you basically have to set up an empty cluster. There's no base backup anymore, okay? And you basically create an empty table on the replica, and then you create a publisher on the primary, you have an empty table on the replica, then you create a subscription or a subscriber on the replica, and it basically will copy the data, not PG-based backup. We're not working down here anymore, okay? We're sending a copy command, the output of a copy command, over to the replica, and the replica is going to replay that and write them into the heap and index files. A little different than before. And then we're going to go into logically encoded WAL, where we're going to read the write-ahead log, we're going to get changes. Just like before, we're getting changes, but instead of them being binary, they're logical. That's why it's called logical replication. The way you set it up is you set your WAL level to logical. You create your publication. You create an empty table. You create a subscription on the replica. And now, if I insert one row, I have one row. If I do the update happens exactly as before, except now we're doing it logically instead of physically. Okay? There are all sorts of unusual configurations you can use for logical replication. You can have one publisher go to multiple subscribers. You can have multiple publishers go to one subscriber. You can have one table going to this one and another table going over here. You can have one partition going here, the other partition going there. You can have odd and even rows if you want, going in different directions. You can even do major version upgrades between these two because of the way that the replication works. Logic replication can be done between major version numbers. Okay? Just to finish up, we have something called replication slots. They are basically pointers in the write-ahead log. We've seen these pointers before. And effectively, it's designed to keep the write-ahead log so it doesn't get recycled. That's all replication slots do, is they allow you to retain write-ahead log on the publisher or on the primary in case the replica needs it. This is kind of the way it works. You can have replication slots in. This is basically your write-ahead log. This is your replication slots, and they basically point to places in the write-ahead log. And this is sort of how you set up a replication slot if you want to create one from SQL. And you end up with this kind of setup. Logic replication slots can also be used for logical replication. And again, you can actually query PG replication slots, and it shows you your replication slots that are set up. So that is all that I wanted to talk about, just to give you an overview of basically how important the write-ahead log is. I know the gentleman before talked particularly about crash recovery, but what you can see here is that replication, that write-ahead log is used for much more than crash recovery. Originally, when we designed it in 2001, it was only for crash recovery. But as you can see over the years, point-in-time recovery, physical replication, and logic replication have all been built upon this change log record. If you'd like to see these slides or 66 other presentations that I have, including 140 videos and 600 or 700 blog entries about Postgres, that is my website down there. And the QR code, I'm sorry you might not be able to see it, but again, if you Google for my name, it will work just fine. Thank you very much.